Dark matter. Everything we see, stars, planets, galaxies, makes up less than 5% of the universe. The rest is hidden in darkness. Astronomers call most of this invisible substance dark matter. It doesn't emit or reflect light, yet it holds galaxies together with its gravity. Without it, stars at the edge of galaxies would simply drift away into space. Scientists first noticed its effects in the 1930s, and decades of research since have confirmed that something unseen shapes the universe. But what is it? Candidates include invisible particles like WIMPs or axions, or perhaps gravity itself behaves differently on cosmic scales. Despite countless experiments, no one has ever detected a single dark matter particle. It's the ghost architecture of the cosmos, the invisible hand sculpting galaxies, clusters, and the vast web of the universe. Dark energy. If dark matter holds the universe together, dark energy is what tears it apart. In the late 1990s, astronomers discovered that the universe isn't just expanding, it's accelerating. That means some mysterious force is pushing galaxies away from each other faster and faster. This invisible pressure makes up nearly 70% of all cosmic energy. Some believe it's vacuum energy, a property of empty space itself. Others think it's a dynamic field slowly changing over time. But no one truly knows. If dark energy keeps accelerating, galaxies will drift so far apart that the night sky will go dark forever. It's the most powerful force we know nothing about, the quiet engine driving the universe toward an uncertain fate. The Great Attractor. In the 1970s, scientists realized something strange. The Milky Way, along with thousands of other galaxies, is moving at over 600 kilometers per second toward an unseen region of space. They called it the Great Attractor, hidden behind the dense stars and dust of our own galaxy. This mysterious gravitational source is nearly impossible to observe directly. Some believe it's a massive concentration of galaxies and dark matter, while others think it's part of an even larger superstructure, the Shapley supercluster. The Great Attractor reminds us how little control we have in the cosmic flow. Our entire galaxy is being pulled towards something we cannot see, to a destination still cloaked in darkness. Eridanus Supervoid. Imagine a region of space so empty that galaxies simply vanish. That's the Eridanus Supervoid, discovered in 2004, a cosmic desert nearly 1 billion light-years wide. It coincides with a mysterious cold spot in the cosmic microwave background, the faint afterglow of the Big Bang. Some scientists think light passing through this enormous void loses energy, creating the cold spot we observe today. But others believe the void is too vast, too strange, perhaps a sign of something even more extraordinary, like a collision between universes. Whether natural or not, the Eridanus Supervoid is the largest known absence in the cosmos, a place where even the universe itself seems to thin out. The Fermi Paradox. With billions of galaxies, each containing billions of stars, many with planets like ours, intelligent life should be common. And yet, silence. This contradiction is called the Fermi Paradox. Where is everybody? Maybe civilizations destroy themselves before achieving interstellar travel. Maybe they're here, watching silently. Or maybe advanced life is so alien that we simply don't recognize it. There's also the Great Filter hypothesis that somewhere between the origin of life and galactic colonization, most civilizations fail. The Fermi Paradox isn't just about aliens, it's about us. Are we early? Are we alone? Or are we next in line to disappear? ʻOumuamua. When ʻOumuamua passed through our solar system in 2017, it became one of the greatest astronomical mysteries of the century. It was the first confirmed interstellar object ever detected, meaning it came from another star system. But what truly baffled scientists was its strange shape and motion. Unlike any comet or asteroid we've seen, ʻOumuamua was elongated like a cigar, possibly hundreds of meters long, and it showed no signs of a comet tail, even as it accelerated mysteriously, as though pushed by an invisible force. Some physicists propose that it might be a fragment of an alien spacecraft, a defunct solar sail drifting through space. Others argued it could be a natural shard from a shattered planet or a hydrogen iceberg sublimating in ways never observed before. Yet, after years of study, we still don't know what ʻOumuamua really was or where it came from. It left our solar system, heading into the dark unknown, and with it, one of the strangest unanswered questions in modern astronomy. Did we just witness the first visitor from another civilization? The CMB cold spot. The cosmic microwave background, or CMB, is the faint afterglow of the Big Bang, a relic radiation that fills the entire universe. But when astronomers mapped it, they found something bizarre, a region known as the cold spot. This patch of space is noticeably colder and less dense than surrounding regions, defying the expected uniformity of the CMB. Located in the direction of the constellation Eridanus, the cold spot spans billions of light years, and scientists are still debating what caused it. Some suggest it's linked to a massive cosmic void, the Eridanus Supervoid, which absorbs and distorts background radiation. Others believe it could be evidence of a collision between our universe and another, a remnant scar from a clash of realities. The possibility that the cold spot might be the cosmic fingerprint of another universe is both thrilling and terrifying, implying that our cosmos may not be the only one, and that the Big Bang might not have been the beginning, but just one of countless births across a grander multiverse. The Multiverse Theory. What if our universe is not unique? The Multiverse Theory suggests that our cosmos is just one of countless universes, each with its own physical laws, histories, and versions of reality. In some, stars might never have formed. In others, Earth might exist, but with entirely different histories, or even alternate versions of you, living out different choices. This idea arises naturally from quantum mechanics, which allows for infinite outcomes, and from cosmic inflation theory, suggesting that space could eternally expand and spawn new universes like bubbles in an infinite foam. If true, the multiverse could explain many cosmic puzzles. Why physical constants seem finely tuned for life, or why the CMB contains strange anomalies. Yet, it also raises profound questions. If infinite universes exist, do we truly matter? Can anything be said to be unique? While impossible to prove so far, the multiverse. White holes. If black holes are regions of space that swallow everything, even light, then white holes are their opposite, cosmic entities that expel matter and energy but allow nothing to enter. Predicted as a mathematical possibility in Einstein's equations, white holes have never been observed, yet they could theoretically exist as the time reversal of black holes. Some theories suggest that when matter falls into a black hole, it could reappear through a white hole somewhere else, possibly in another universe, an idea closely tied to wormhole physics. Others propose that the Big Bang itself might have been a white hole, an explosive release of all matter and energy from singularity. While white holes remain purely theoretical, they challenge our understanding of space-time and causality. If proven real, they could reveal that black holes aren't dead ends, but cosmic gateways, doors through which the universe recycles itself endlessly. Heat death of the universe. Far in the future, long after stars have burned out and galaxies have faded, the universe will face its ultimate fate, heat death. In this scenario, the cosmos continues to expand forever, until all energy is evenly distributed and no thermodynamic work can occur. There will be no light, no motion, no life, only darkness and cold equilibrium. Every atom will eventually decay or drift apart as space itself stretches beyond comprehension. This is the destiny predicted by the second law of thermodynamics. Entropy always increases. Heat death is not an explosion or collapse, but a slow, quiet dissolution, a universe fading not with a bang, but with an infinite whisper. It's the most haunting mystery of all because it's inevitable. One day, even time itself may lose meaning as the last remnants of energy dissipate into the void, leaving behind only the eternal silence of a universe that once was.